Today we are talking about the last two transformations. One of those is rotations, and then the second one is dilation. So the first one we're going to talk about is a rotation. And if you notice in here, it says a rotation turns a figure about a fixed point, and that point is called the center of rotation. So let's take, for example, even this windmill or pinwheel over here. This guy right here would be called the center of rotation. So we are basically taking a figure and we're rotating it about a specific point. So even on the coordinate plane, if you look at this example right here, this is called your center of rotation. And as always, there's a specific pattern that we're going to take a look at when we rotate. So let's take a look at, first of all, when we rotate from here to here. So if you look at the point 1, 1, it becomes the point negative 1, 1. Let's take a look at another point. If you look at the point 5, 1, it became the point negative 1, 5. Let's look at another one. 4, 3 became the point negative 3, 4, and 3, 3 became the point negative 3, 3. Let's focus in on just one point to maybe make it a little bit easier. Let's take a look at the point 4, 3, and I'm going to write it up here. The point 4, 3 became the point negative 3, 4. And so we're going to look for a pattern. Well, first of all, if you notice, these flip locations, and then in turn, this one became a negative. So we're going to go write that down here. So if it's a rotation of A, B, what happens is, I'm going to grab a smaller pen. That became the point negative B, A. So again, they flip locations, and this one became a negative. Now let's go look at a rotation of 180 degrees. So again, let's take a look. You've got 1, 1 to negative 1, negative 1. 3, 3 became negative 3, negative 3. So first of all, notice they're both becoming the opposite of what they were, but let's see if they're changing locations. Let's look at this one. 5, 1 became negative 5, negative 1. So in that particular case, these values didn't change, but they did change signs. Let's look at one more. 4, 3 became the point negative 4, negative 3. So that means down here, we end up with the point negative A, negative B. And for your quiz, you're going to be allowed to use this. So just make sure you've got filled in what the rules are. Now let's take a look at 270 degrees. So again, 1, 1 became 1, negative 1, which again, when these coordinates are the same, it's hard to see what's going on. So let's focus here. I've got 5, 1 became 1, negative 5. So again, if you notice these flip locations, or excuse me, flip coordinates, but in this case, it's the second value that became a negative. Let's look here. 4, 3 became 3, negative 4. So in other words, similar to this one, they flip, but in this particular case, it's negative A on the Y coordinate. And these rules are only holding true when we turn about counterclockwise. And in general, if we say we're rotating, it's understood to be counterclockwise. If it's going to be something else, then it would denote that it's going to be something else. So let's go look at an example. They want us to plot the following points. So let's go ahead. We've got the point 3, 1, which is point A. We've got the point 3, 4, which is B, and the point 1, 1, which is C. And they want us to do a 180 degree rotation. So if you look at the rule, what happened, each one of those points, the X and Y coordinates stayed in the same location, but they flipped signs. So in other words, the point 3, 1 is going to become the point negative 3, negative 1. The point 3, 4 is negative 3, negative 4, and the point 1, 1 is negative 1, 1. So let's go ahead and plot those points. We've got the point negative 1, negative 1. We're going to label that to be C prime. We've got the point negative 3, negative 1, which is A prime. And then we have the point -3, -4, which is B prime. And again, just to kind of reiterate, this is called the pre-image, and this one is called the image. All right, let's move on to the next one. They want us to take the point 1, -3, so 1, 1, 2, 3, which is point R, and then 2, -5, 5, and they want us to rotate 180 degrees, and then we're actually going to reflect it across the y-axis. And actually, just to change it a little bit, since we did 180 here, let's go change this to 90. So if you look at your formula here, AB became the point -B, A. So that means the point 1, -3. We're going to flip the locations and change the sign. So we flip, that becomes a -3, 1. But then I have to change the sign on this, so it's a 3, 1. Let's go to the next one. We've got 2, -5, so again, they change locations. It's -5, 2, and again, we change the sign from a negative to a positive. So let's go plot it and see if that actually happens. So we've got the point 3, 1, and we've got the point 5, 2. And this is R prime, and this is S prime. That's kind of tough to see. It's a 90-degree angle, but one way we figure out what that angle is, if you take your pre-image point, you go to the origin, and you go out to R prime, it should form a right angle. Same thing if we did S to the origin, out to S prime, it forms a right angle. So we know we've got a 180-degree rotation. Then they want us to reflect it across the y-axis. Here's your y-axis. So here I've got the point 3, 1. I'm going to reflect that, so that would become the point -3, 1. So there's R prime. Then I've got the point 5, 2. So again, I'm going to go over here, 5, 2. Didn't do this very well. Let's label this to be S prime, and this is R prime. And so now we've reflected it across the y-axis. Okay, last little piece they talk about in the figure, a plane has rotational symmetry when the figure can be mapped onto itself and end up back at the same location. So in other words, if you take a look at this guy right here, I can actually turn my paper 60 degrees and I end up at the exact same location. So take a look, 60 degrees and I end up at the same location. I could rotate another 60 degrees and end up at the same location. So this has a 60-degree rotation symmetry. If we take a look at this one, kind of the same thing. I could, if you notice it's regular, if I do 360 divided by 5, that lets me figure out how many degrees I can rotate and again end up back at the same location. Same thing here. If I take 360 and I divide it by 4, I end up with a 90-degree of rotation. So every 90 degrees I rotate, I end up again back at the same figure. So take a look. There's 90-degree rotation, there's another 90-degree rotation, and if I rotated it one more time, another 90-degree rotation, and I end up with the same figure. Okay, I'm going to pause for just a minute, make sure you guys are with me, and then we will move on to the dilations. Okay, the last transformation is called a dilation, and I want to point out we had talked about a word isometry at the beginning. Isometry means that you end up with the exact same size. This one is not an isometry because we are either enlarging or we are reducing that figure. A prime, B prime, C prime is so if we're looking at this guy to this guy, it would be a reduction because it's getting smaller. And if you take a look at any one of the points, You're going from 1 to 0.5, or 6 to 3, or 5 to 2.5, or 6 to 3. That lets us know the scale factor is 1/2 or 0.5. In other words, you take the length of the new image divided by its corresponding length of the original image, and you end up with 1/2. This point right here is called the center of dilation. So all of the figure is dilating about that specific point. So really all we're doing is taking that scale factor and applying it to every single coordinate. Let's go over here. They want us to find the scale factor and notice, is it an enlargement or a reduction? So here you're going from A, B, C to A prime, B prime, C prime. And we can take any one of those points. I'm looking at point A is going from 1, 1 to, it looks like here, 3, 3. Let's take a look at another one. Point C is 3, 2, and we're ending up at 9, 6. So we're looking to see, first of all, we can see it's an enlargement. And we're looking to see what that scale factor is. So again, you can look at any individual coordinate or any individual point and look to see what are they doing to get from here to here and make sure it's applying from here to here. It looks as though they're multiplying everything through by 3. So that would mean our scale factor is equal to 3. Okay, let's go down to this one right here. I've been given the length from here to here is 3. And my length from here to here is 12. And it's hard to see which ones are prime and which ones are not. I'm going to look as though we're going from here to here. So again, that's an enlargement. And how do I figure that the scale factor out? I take my new length, which is 12, divided by its original length, which is 4. So again, that tells me my scale factor is 4. Okay, let's go to look at this example here, and we're starting with, let's go write out all those points. I'm going to go pause it and write those down to start with. Okay, and it says to apply a scale factor, and we're just going to keep it as a positive. We're going to change it to 1/2 to make it a little bit easier. So I'm going to take each one of these coordinates and multiply it by 1/2. So 4 times 1/2 is 2. 2 times 1/2 is 1. 1/2 of -4. 1/2 of 5, 1/2 of 1, and 1/2 of -3. Now we're ready to plot those points. So we've got the point 2, 1. We've got the point -2, 2.5, and then 1/2, -1/2. And we can definitely see it's a reduction, and we can see it's by 1/2 because we were told that and we applied that as well. So to summarize, what we really did down here is we took each one of those x and y values and simply multiplied it by k. So let's take this last example. We've got the point 2, 0, we've got the point 2, 2, and the point 1, 0. So this is R, S, and T, and they want us to apply a scale factor of 3. So let's go take this. That becomes the point 6, 0. So let's go ahead and we've got 2, 2 becomes the point 6, 6. And then finally the last point 1, 0 becomes the point 3, 0. And going ahead and sketching that in, and I guess this last point should have been a T prime. Okay, and that's it for the dilations. I know we're kind of going through these pretty quick. I'm just trying to get this little small unit done before we are done and headed on spring break, which is on Thursday. So we've gone through the 4 transformations, the dilations, the rotations, the reflections, and the translations. And we will have a small quiz coming up on Wednesday or Thursday, depending on what period I have you. As always, send me an email if I can help you out in any way. Thanks so much. Bye-bye.